Welcome, viewer, to part 3 of the TitanBot series. In this episode, we are going to be building a component for the robot called the vertical frame rail. This is a non-handed symmetric component. That means that we're going to be able to model this part once and use 2 of these to create the central feature of our robot. This part adds to the overall rigidity of our robot. It helps to minimize vibration, but it also performs a useful service. It supports the battery tray for the robot. It contains the logic tray for the robot. So this is where the Arduino Uno and motor drivers are going to be located. And it also incorporates some standoff bosses where the robot shells will be connected. So let's get started building this part. I'm going to create a new body, and we'll create a sketch to go with that new body, and we're going to do that on the XY plane. And I'm just going to zoom out a little bit so I can see the extremity of the x-axis. And I'm going to begin now by grabbing the polyline tool. And I'm going to create a shape around the origin here that incorporates those standoff bosses. We want to make sure that our lines are constrained as horizontal and vertical, so we can see the horizontal and vertical constraints on all of our lines here. The next thing that we need to do is we need to constrain this shape. So we're going to start with these standoff bosses. We're going to both make them the same width. We are going to make them symmetric with respect to the y-axis. And we are also going to set the height of these bosses. So we'll set this to 35 millimeters. We'll set the width of the bosses to 9 millimeters. And now that we have the bosses sorted out, let's set the overall height of the vertical frame rail. We'll set that to 85 millimeters. And we'll set its overall width to 94 millimeters. Next, we have to set the position of this with respect to the origin. So we're going to set it so that it is 22.2 millimeters away. So there we are. We've now fully constrained the outline of our vertical frame rail, so we can close that. And we're going to pad this shape out to 3 millimeters. Next, we are going to add a number of features to our shape. First feature that we want to add is a number of indexing slots that the battery tray and logic tray will connect with. I'm going to use this rectangle tool, and we're going to create 6 rectangles. And these rectangles are going to be symmetric around the origin as well as around the X and Y axis. So we're going to start by taking these 2 outer squares and making them symmetric around the y-axis. We're going to take the central rectangle and we'll make it symmetric around the y-axis. We need to make all of these rectangles collinear. So we're going to select a vertex from each one of them. And we will constrain them so that they are horizontal. So they all move together now. We are going to constrain these 2 rectangles on the left-hand side so they're symmetric around the x-axis. And we're going to make all of the rectangles on the bottom collinear, selecting a vertex from each and constraining them horizontally. We also need to constrain the central boxes so that they are collinear, as well as the rectangles on the right-hand side. So those have all been constrained vertically. Now we need to set the size of the width of each of these rectangles so that they're the same. And we're going to set the height of all 6 rectangles to be the same. So select the edge and set them equal to each other. Now at this point in time, we just want to check to make sure that when we move one edge of the rectangle, we are seeing symmetrical movement in all of the boxes, and so we are. So now we can proceed to constrain the dimensions of our rectangles. So I'm going to constrain the width of the rectangle to 10.2 millimeters. I'm going to constrain the height of these rectangles to 3.2 millimeters. I want an overall distance between these two outer rectangles to be set to 53.8 millimeters. And now we're going to set the distance between the first and second row to 31.4 millimeters. And at this point, our rectangles are fully constrained, and so we can close out of this sketch, and we're going to pocket these shapes. Now we're going to left click on the top face and create a new sketch. And now we're going to add some mounting points for the shell on our standoff bosses, as well as adding the holes that will allow us to connect this vertical frame rail to the pedestals that will retain this to the primary platform, primary mobility platform for the SparkBot. So just add in these circles here. And the first thing that we're going to do is we're going to make these pairs of circles symmetric around the y-axis. So we'll do that for each pair. This has the helpful effect of also making each hole collinear, which is very helpful. Now that we've done that, we are going to make it so that all of these holes along the left-hand side, the top three here, we want those vertically aligned. And now we're going to set the two top holes so that they have an equal diameter, and we're going to set the diameter of these top holes to 4 millimeters. The next four holes we need to set equal, and we're going to give them a diameter of 2.8 millimeters. We're going to create a separation distance between these two bottom holes of 85 millimeters. And then we're going to come down to these bottom two holes. These are what mount to the rails, the pedestals at the bottom of the frame rails. So we'll set these two circles to have the same sized diameter. And we'll set the diameter of these holes to 3.2. This will allow the 3 millimeter screws we're using to slide right through the holes. We're going to separate these holes by a distance of 39 millimeters. And now we're going to set the height of these holes with respect to the left-hand edge of our vertical frame rail. So we're going to left-click the center of that hole and select the bottom edge. And we're going to set that to a distance of 4 millimeters. And then we're going to set the height of this next set of holes with respect to the bottom of the frame rail. And we're going to set that to 48.6 millimeters. And then we will reference the top of the standoff boss here for these next two. So we'll set the height for this top circle. That will have a 4 millimeter distance. And then we will reference the center of both of these two circles to give us a distance of 9 millimeters. So we now have the anchor points for our shell on our standoff bosses. We have holes for mounting this to the pedestal that'll sit at the bottom of the frame rail. And because we're fully constrained, we can close out of this. And we will pocket those holes. And the next feature that we need to add to this is a couple of holes down at the bottom of the frame rail. These are going to be used for routing some of the wiring that needs to pass across the TitanBot. So we're going to reference the bottom of the frame rail here, and we're going to begin by creating 2 rectangles. And then we're going to create 2 arcs. And these arcs are going to have the center point locked to the bottom reference point here. You can see that you have to fiddle with the second arc because it tries to wrap around the bottom of the shape. All right, once you have your 2 arcs created, grab the line segment tool, and we're going to create a line that closes off these 2 arcs. Right-click to clear your tool. We're going to set the size of these 2 arcs to have the same radius. We're going to set the width of these rectangles to be the same and the height of these 2 rectangles to be the same. Now we're going to make both sets of shapes symmetric around the y-axis. Do that for the internal vertices of the arcs. So now that both of these 2 sets of shapes are symmetric around the y-axis, now we're going to constrain the width of one of these rectangles. So we'll constrain that to 5 millimeters. And we'll constrain the height of these rectangles to 3 millimeters. We're going to constrain the radius of the arc to 3.5 millimeters. And we will set the distance between these 2 arcs by clicking on their innermost vertices, and we'll set that distance to 11 millimeters. And our last degree of freedom is going to be the distance between the innermost vertices of our 2 rectangles. We'll set that to 71 millimeters. And so at this point, our features are fully constrained, and so we can close out of the sketcher. And we will pocket these features all the way through our vertical frame rail. Now we're going to add a triangular truss lattice to the center of the shape. We're doing this primarily for weight reduction. We want to try to make this robot as light as we can. So we're going to use the polyline tool here, and we're going to create 5 triangles. And we'll constrain them so that they're all identical here. But we'll just rough them out to start with. Now, once you have your 5 triangles, we are going to begin by making sure that the base of our triangles, the bases of our triangles are all equal. And now we're going to use a geometry construction line to help us space out our triangles here. So we're going to add construction geometry between the top of our triangle pieces. We also want to reference the edge of our vertical frame rail here, so I'm going to use the external geometry tool and reference those. Then I'll use this, bring in a construction line right to the edge of our shape. Now we want to make sure that all of our lines have been constrained horizontally. So we'll select the ones that don't have their horizontal constraints and fix that. Next, we're going to make sure that each of our construction line segments is equal. So we'll make them all constrained equally. And now we are going to make sure that our triangles are all the same size. So we're going to do this by left-clicking the edge of the upright sides of each one of our triangles, and we will set them so that they are equal. At this point in time now, we can set the spacing for our triangles. So I'm going to use the dimension tool, and I will set the width of just one of these spaces. And then we're going to set the height of our triangles. So we'll pick two edges or two vertices. And using the dimension tool, we'll set that to 24 millimeters. And then we will position these triangles with respect to the origin at half their height. And so now our truss lattice, which borrows from bridge construction, not technically necessary, but it does allow for airflow and does lighten up the plastic that is used a certain amount. We're going to close out of this now that we're fully constrained, and we're going to pocket these shapes. All right, so we're getting close there. We're going to add a functional feature and a cosmetic feature here. The cosmetic feature will be at the top of the standoff bosses here. We're just going to add a fillet. So I'm going to click on each edge and then control click on the remaining edges. So I have selected all four at once. And I am going to give it a fillet of 4 millimeters. And so that is the aesthetic modification. But down here, we need to give it a functional modification. When we are routing wires down past the edge of the vertical frame rail, we need this feature to have a bit of a rounded edge so that it doesn't end up grabbing the wire as we're pulling it through. So 2.5 millimeter fillet on that will make it so that the wire can be pulled through between the vertical frame rail and the pedestal. Now we're going to add a couple of tie points for wiring that needs to be routed around the inside of the TitanBot. So we will create a feature on the outside of the frame rail here. And we will just begin by making two rectangles on the face of our vertical frame rail. And we will make both rectangles equal in height, and we will make them equal in width. And we are going to make them symmetric with respect to the y-axis. Now that we have done that, we are going to constrain the width of this rectangle to 3 millimeters. We will constrain the height of this rectangle to 9 millimeters. And we will constrain the distance between the inner vertices of these rectangles. We will constrain them using the dimension tool to 84 millimeters. And the last thing that we need to do is set the height of these rectangles with respect to the bottom of the vertical frame rail. So I'm going to use the external geometry tool, reference the left-hand edge of our component, and I'm going to set the height with respect to the bottom to be 28 millimeters. It's a somewhat arbitrary point. You could have tied it right into the x-axis if you wanted, but there we go. So we're fully constrained, and we can close out of this. Now we're going to pad out this feature, and we're going to give it a height of 7 millimeters. And now what we're going to do is we're going to create a hole through this feature. I'm just going to view this section, and I'm going to use the external geometry reference tool to pull in the left edge, and I am going to create a circle at the center of this new feature with a diameter of 4 millimeters. Going to position it with respect to its the top left corner there. So we're going to set that to 4.5 millimeters. This will center it. And we're going to set its position with respect to the face of the vertical frame rail. And we will set that to 3 millimeters. So now that our part is fully constrained, we can close out of the Sketcher workbench. And we're going to push this hole all the way through both of these features. And we will do that by creating a pocket that extends the length of the vertical frame rail. So now we have a hole through both of these tie points. And we're going to provide an aesthetic fillet to the edges of this, like we did at the top of the standoff bosses. And now our part is feature complete. So 3D print 2 of these, and we will mount them to the pedestal that we created in part 2.